Today we have another very important topic related with testing and calibration or verification of CMM, and as per ISO, CMM in ISO, we have with us Professor Vinay Arun Kulkarni, who is from Divai Patil Engineering College, Pune. Sir, thank you very much for accepting our request. As we are all aware, you are busy with your lot of other things. Thank you very much. With your busy schedule, you have find some time to enlighten us with your great experience and knowledge about this very interesting and the important subject. How to do this type of calibration and testing? It is a very important part, sir. Now I would like to request you kindly take over and enlighten us with your knowledge. Mr. Kulkarni, please, sir. We have another expert in between, and certainly we will introduce him also, as Professor Kulkarni is an expert in this field. He is a professor in a college, engineering college, IP, in the Patil Engineering College at Pune, and we are all aware it is one of the best college which is working, not only preparing the students, but doing a lot of R&D. He has a lot of research papers, his PhD students, and all the things which a professor used to do. Sir, we would like to take your help not only for this lecture, even after that for the development of our standards in our country. Thank you very much, sir. Please, over to you, sir. Thank you.
Thank you, sir. Thank you. Thank you very much, Ashutosh ji, for your kind introduction. And I hope that I will be doing my level best to explain a case study about coordinate measuring machine and how ISO 10360 and other ISOs helped us in preparing the interim check of the CMM machine. Dear friends, all of us, we know coordinate measuring machine is a very like a suspended probe in the air, and it has as good as all kinds of errors in it, and to check that error and to again checking, not only just checking that error, but to incorporate in measurement, it's very difficult. But as our standards are very nicely substantially merged into and integrated into to show this how we have done it. So I am going to share with you a case study wherein we have developed an artifact for interim check of the coordinate measuring machine. Dear friends, ISO as per IS 15635 2006 definition, or 10360 that is in 2001 definition, it defines a CMM as a moving probe system which determine the special coordinates on the workpiece. On the workpiece, that is, we can develop and accordingly do the workpiece here. So here, the most important is that the probe is like a suspended thing in the coordinate measuring machine on the moving bridge, that is we call it as car, and picking up the dimension, picking up the coordinates and measuring its dimension, tolerances and other parts are very important for all of us. But when we say that it is a very precise machine, maintaining its precision is a very Herculean task. It's not that easy at the same going, because meteorological conditions, all of us we know, that is 20 degrees centigrade temperature and the defined range of humidity is always very important. Therefore, for verification of CMM, ISO 10360 in 1994 started giving the regulations for all of us, that is verification of CMM. Verification of CMM should be done in the two ways. One is called as a primary cycle, that is 1 year period, probably we take it, that is called as calibration period, and secondary is the interim check. Now what happens is, today is our machine is calibrated, and let's say we are having the calibration cycle fixed up by next year, then error gets started inducing about this, and this error will keep on creeping inside the system, because CMM is a system. It's not just a measuring device or a measurement machine. It's an entire system that is picking up the coordinates and then going for the computerization and then checking out how it is required here. So therefore, for verification of CMM, we always require to check regularly between 2 periodic intervals. Any 2 periodic intervals, we can just check it out. We can do that. An interval is based on the environmental condition. That is very important here. So we have to keep the environmental condition also ready. ISO 10360 describes the requirement of measurement of physical artifact or standardized performance evaluation methods. Because laser interferometer cannot give you the dimension directly. It will give you a form of the CMM, but not the dimension. For the dimension, we always need an artifact. That is for the interim check here. Advantage of artifact is it enables the variation in probing point, coordinates, and deviation. It also quickly mimics how we are measuring by using CMM. And because of that, mitigation of the errors in the CMM performance is very easy. At the same time, in laser interferometer, even if you are using laser interferometer, it's a non-vector driven CMMs. That is, diagonal measurement by laser interferometer is really very difficult. That is not possible. At the same time, laser interferometer will not reflect how we are calculated the dimensions by using the CMM. So that's a major disadvantage we can say. So let us see the journey of ISO in CMM. ISO 15530-3 in 2011, it specifies the evaluation of measurement of uncertainty. Measurement by CMM using a calibrated workpiece or a measurement standard. This is very important here. Why calibrated workpiece is required? Because its dimensions are known and we are comparing CMM whether it is going to give the same dimension or not. Now, let's say, for example, we have checked the roundness by using Taylor Hobson, more sophisticated measuring device. And then we check the same in the same condition, whether the CMM also gives the machining same condition or not. That is traceability standard. By defining the experimental technique, this is what they have defined in ISO 15530. And ISO is nothing but all of us, we know it's like a guideline. And the guidelines, and at the same time, the ISO is an international standard, whereas Ashutosh sir and his team is doing in the Indian way, how it is important. Because just copying at the global level is very suicidal for all of us. We know in India, the temperature variation is quite larger. In fact, in Pune, dear friends, let me tell you, from the morning 5 o'clock to evening 6 to next day morning 5 o'clock, the temperature varies so rapidly here that it is really very difficult to maintain that temperature. Therefore, I really want to congratulate Ashutosh sir that you are defining so much of the importance that is given in here. And think globally and act locally. That is what you people are doing. Hats off to all of you, and your team, sir. For simplifying the uncertainty evaluation of CMM measurements, the specially ISO 15530 specifically give us the recommendation of using the artifact. That's why it is very important. Measurements being carried out in the same way as the actual measurements. This is a major important element in ISO, that just like laser interferometer, normally we feel that laser is more accurate and laser interferometer will give you quite a good amount of readings. Dear friends, it gives a reading about the CMM form. Even if we understand this today, I think Ashutosh sir, we have been successfully doing this for this particular lecture. That is, it's not just only about the form of the machine, it's how it measures. That is very important for all of us. So deviation as per the actual measurement that need to be carried out here. Similar dimension and geometry, dimension and geometry instead of unknown workpiece to be measured. So workpiece to be measured, that is compared with the known geometry. This is a very important thing. There are a lot many artifacts in the market. One is the ball bar. Second one is step gauges. All of us, we know how step gauges are very popular in as compared to the ball bar, because it contains the specific dimension. At the same time, its manufacturing is also very easy, bit easy. There is a hole plate and ball plate. This hole plate and ball plate gives a combination of the experimental setup that I am going to show this to you. Then the space pin, any other thing we can do it here. How we choose a material for the artifact? That is, material should be high coefficient of thermal expansion, difficulty in movement by operator due to heavy weight, low coverage measurement volume. Now, this is probably the most important thing that we have developed a case study. I'm going to just share with that is been there in here for ball plate, because ball plate gives certain important advantages, because in ball plate there is a ball and that gives a normal vector. we can actually measure by using any normal vector, and calculation by that vector through linear dimension is very easy by distance learning formula. That's the reason why we are using this ball plate here. How this ball plate is defined and everything I am going to explain here. Acceptance and re-verification test. These are again ISO standards by ISO 10360. Basically, ISO 10360 defines what is the acceptance test, what is a performance test, and the characteristics components of measurement deviation, that is 3, 4, 5. This is what is given here in the amendment. Nomenclatures, terms, and conditions is in ISO 10360-1. Measuring uncertainty is again measured in 3, 4. And now the new ISO has came into existence, that is calibrated arm 10360-12. If you look at the diagram here very carefully, dear friends, then probably I will just say that this measuring volume on the CMM machine can be converted into blocks. The block which is very much near to the probe and the block which is near very much to the workpiece. And remember, when this block is losing its shape, because ultimately the probe must be traveling exactly perpendicular to the axis of the workpiece, as well as exactly parallel to the axis of the workpiece. That is very difficult. For that reason, what we are going to do it is the combination of ISO guides us actually. So this is what I have just narrated here, that in ISO 10360 in 2000, there was a terminology. Basically, sir, CMM was not having any ISO standard or any other standard till 1994. After 1994, we started making this kind of ISO standards, because CMM is basically, people say that it's a very precise machine, but I will say it other words, that is CMM is a very unprecise machine if we are not maintaining the meteorological conditions. That is very important for all of us. And that's why you can see in 2009 ISO 2, that is made at a length test. That is how we can make a contact probing system. That is MPA, maximum permissible errors, and other things. Then in 2000 rotary table test, for that we are having that ISO standard. Then contact scanning test is in 2000. Then contact probing test, it is in 2010. For software testing, it is 2001, because software is the most essential parameter of CMM. Basically, CMM picks the coordinates, but then other juggleries, I will say, that is how to make a circle, how to make a sphere, and how to make a parallelism, how to make a conicity, and other GD&T is the software who does this actually. So CMMs with imaging probing systems, that is how we can make a cloud computing, and based upon that 2011 it was decided. Then optical distance sensors 2013. Again in 2013, CMMs with multiple probing system was being developed here. Then last one is right now in 2023, it is ISO 10360-12, and laser trackers are also been getting off. In short, I will like to summarize in this way, that if you want a profile of the object, that is how it is circle, how it is cylindrical, and other things, then CMM with laser system is very essential or prove to be its worth. But when we want to measure the dimensions, let it be any measurement, including the diameter, including the length and everything, then the most important, dear friends, here is the CMM touch probe system. I will not say trigger probe, because that has gone now. The touch probe system, that is very important for us. Probably this is what the most important diagram that we can develop here. The green line shows all the green line here. All the green line shows the measurement volume without any machine error. But there are errors in the system. That is, one is, let's say, yaw, roll, pitch. Yaw, roll, pitch is for all dimensions, for all three dimensions, that is X, Y, Z, make the machine very complicated here. And because of that, what happens is there is a drift in the measurement system. Let's say now this particular point here, this particular point has been shifted to this point. Let's say this particular point has been shifted to this point here, right? This particular point has shifted to this point. So if we shift here like this, what happens is that there is a pitch error, there is a yaw error, there is a roll error, and probably I think right now the right now any artifact if you take, then the roll YZ error is very difficult to calculate, is very difficult to compute. We here claim that we have developed an artifact wherein we can do all types of error except roll Y and roll Z error, in fact, and we are trying to make it now an artifact which is most suitable for this type of error as well. But I'm just sharing with you right now the case study how we can develop here. So there is a roll Y, roll pitch Z and pitch X in this direction, and then all types of combination that it goes. You can imagine that it's just like an aeroplane suspended in the air, wherein the aeroplane trying to move towards the right direction and the aeroplane trying to come down, aeroplane trying to dip down, aeroplane trying to move up. In that case, we control yaw, pitch and roll only. That's the Drugger system and other systems that we can do it here. Similarly, we can develop it for the CMM machine, dear friends. And because of which, now majority of the times what happens is we use the step gauge. The step gauge, which is not exactly volume, same volume as that of the CMM machine here, measuring system, let's say. Now, in this measuring system, what happens here is we need, let's say now we are having a CMM working volume as 300 mm by 300 mm by 300 mm, let's say. Then we want an artifact which is exactly at 300 mm by 300 mm and 300 mm. But the problem is, dear friends, that we are having a step gauge of 50 mm. Normally, we do that 50 mm, half a measurement volume. The step gauge reaches only to this point. But then we try to speculate here by using regression analysis. And because of that, this happens in this way. So that doesn't count any something else. Therefore, we have developed this ball artifact. You can see this is a ball artifact in which, and sir, I am very, Ashutosh sir, I am very proud to tell you that we have made this indigenized ball plate, sir, by using dolerite. Dolerite is a granite that is we have got from GMT machine tools, that is Goendy machine tools in Hosur, Bangalore. And from that we have given it, and it's a very good metrological properties. Most of the times granite is having porosities, and because of that, then expansion is very much higher. In this case, we have developed this dolerite as a ball plate, and this round ball are being made up by zirconia, sir. This is not made up by other material that we are using for the probe very much, but it's a zirconia. Balls, and I'm very happy to tell you, sir. Now we are manufacturing this in Pune, in Hadapsar, also these type of balls. Previously, when I was doing this research in 2021, I have got these balls from Sussex, England, and from that we have been developed this because we require this roundness of 0.7 microns. Otherwise, if the roundness is not maintained, then probably spatial verification is going away. So we have made a number of ball plates. Out of that, this ball plate we have chosen because its weight is only 14 kgs. We can manually handle it, and it doesn't require any kind of other support. Otherwise, there is a probing system, and then we can make it a heterogeneous system. And because of this heterogeneous system, now what happens is there is always a temperature difference. So difference of temperature coefficient, that's why it's very important here. That single plate geometry with symmetry array of balls that we have been produced here as a ball plate artifact for doing this matter here. So what is the specialty of this ball plate? That is entire measuring volume. It covers entire measuring volume. And I'm very happy to tell you that experts from Accurate Engineering, Hexagon Metrology and Renishaw, we three come together and develop this. Average measuring volume of CMM is in the range of 450 to 500 mm in box shape. So this box shape, this array of small steps here, as per the CMM verification guide by NPL 42, we have developed this. And at the same time, it caters the need of ISO 1360 as well. So because it is recommended that spheres up to 30 mm diameter, which is a probe qualification, that exactly the same probe we have used here. And the reference sphere is 25 mm diameter used in various CMM, but we have used it as 30 mm. So this is the production drawing. Sorry. So this is the production drawing here. And in this production drawing, as you can see, we have added few more slots here. Few more slots so that the stability of the temperature also increases at the same time. At the same time, it is having less material weight. So these balls are been fixed up in this array. As I already told you, we can make shift of change of these dimensions here. So this we can do it. And when we do temperature analysis, that is thermal diffusion, we can see now that the maximum the temperature difference here, directional deformation because of the deformation here is at the end of the plate. This is at the end of the plate, not at the any of the side of this or any towards the ball plate. So even if we are making this 20.05, 20.5, sorry, 20.50 degrees centigrade, then also it is showing here. And at the same time, what we have done is we have made the calculations here. That is what will be the drift in the temperature in X, Y, and Z axis on 20.5, 21, 21.5 up to 24. We have taken this, and what is the drift that we have measured? As you can see, this is the total drift here, and that is up to 3 microns. Now, dear friends, all of us, we know that if there is a Y error, Y pitch error in CMM, which is of more than 5 microns, we again go for recalibration, even though the interim check periods are not over. So that's a given thing that we can do it here. And at the same time, as you can see here, that the artifact is recommended to be used up to 22.5 degrees centigrade. So it is holding its position maximum by 22.5 degrees centigrade as it limits the total deformation below 2 microns. So below 2 microns, is a standard for any artifact to measure the flatness, sorry, to keep intact the flatness, then other things. The best use of artifact is recommended up to 21 degrees centigrade here. But however, the yaw error of CMM in y-axis goes beyond 5 micron, the CMM is referred for recalibration. So we can use it up to 22.5 degrees centigrade temperature here in India. And as you can see, these are the actual ball plate variation. And we added here 2 more slots. You can see this slot number 1, then 2 here, then 3 and 4 in half axis, and then 5, 6, 7, and 8 in the complete axis here. And this ball plate is having its width here. It can stand alone without any support. So that gives almost a homogeneous structure of the ball plate. I'm saying almost a homogeneous structure because you know that we are having this zirconia ball, and this zirconia ball is having a great property here that even if you drop down on the ground, its flexes will not come out. That's called as flexural strength. At the same time, these balls can be fixed up by using a glue. Previously in ball plates, we are knowing that if we want to make a T slot here and to make it exactly in the slot, we need to drill by using ECDM process or by using EDM process. Now that EDM process is very costly. Therefore, without external support, we can do this. This is a Guindy machine tool certification that I'm just showing to all of you here, that the flatness, you can see the flatness I have in fact suggested here, that is 3 micrometers should be the flatness and squareness and parallelism. But thanks to GMT that they have achieved to 2 microns, 2.5 and 1.5. And this was greatly supported by them because they have told me that this is the first time in India they are developing up to this standard that is so low, and Dolerite could easily achieve it. That was very really great efforts. So how is the total Dolerite ball plate? I will say zirconia Dolerite ball plate, because this is a ball plate means there is a plate and at the same time the balls are attached. So these are the dimensions: 450 mm by 450 mm by 40 mm. This is covering maximum measuring volume, that is 450 mm entire maximum volume it is covering. Thermal stability up to 22.5 degrees centigrade. Soaking period is of 3 hours. So as compared to 22 hours in case of stainless steel products or any other ferrous based, 3 hours is much more achievable. Higher flexural strength, weight is only 18 kgs here, and form is 2.5 microns on all faces. That is very important. That can be retained here. Measurement is ball distance of 50 mm, and the measurement grid is 50 mm cube. In the 50 mm cube, you can measure the grade here. No external support is required, and the entire cost of manufacturing is 1,19,041 rupees, dear friends. Low operation cost, as routine CMM operators can perform the interim check. Now just imagine that if you want to make it by using laser interferometer or any other dimensional checks, the cost of the calibration of that CMM itself is going to not now in that kit, it is the cost is only 1,19,041 rupees, in which we have programmed also, that is the program is also ready. We have to just fetch it to the machine. It calculates the errors into that. Holding and handling, both serve ease of holding and handling. 40 mm thickness can form griply, and 2 operators can easily handle the ball plate. That is very important here. So what is the dimensional stability of artifact? Now this is very important. So what we have done is we have established a autocorrelation of Six Sigma tool here. At the same time, there are 2 relationships in the series. One is 1 to 1 to 2, 1 to 3, 1 to 4, 1 to 5, like this. And at the same time, 1 to 2, 1 to 3 is repeatable. That is what we want here. Now you can see, if I number here the ball plate here, you can see this is the 1 number, then 2 number, 3 number, like this. So these are the continuous numbers that we are making here. So 1 to 2 distance means this distance. 1 to 3 means this distance. 1 to 4 means this distance. Here 1 to 5. It's just like in case of incremental programming in CNC machine, so that we will maintain the tolerance stack very less. Otherwise, what will happen? Now, let's say, for example, if you are having 1, 2, 3, 4, 5, and 6, these are the dimensions. 1 to 6, if you want to make it, then normally what we do is we want to make it 1 to 2, then 2 to 3, then 3 to 4, like this. But then if we develop like this, then the tolerance stacking will result. Stacking of the tolerances. That's why we are conducting here 1 to 2, 1 to 3, like this. Okay. At the same time, you can see now, this is the 9 balls here, then it is 17 balls here. So this is the size. This is how the ball numbers are been computed here. You can see this is a ball number have been computed here. So 17, then 25, then 33, and there are some dimensional also. You can see dimensional as well. These are the ball plates which are dimension here, and the total ball plate number is 42, as you can see. Okay, total ball plate number is 42, dear friends. So when we measure by using SPAT probe, we all know it's very accurate, and in fact the cost is more than 30 lakh rupees. I'm very much particularly thankful to Accurate Engineering for giving this opportunity that we can measure it here. You can see 1 to 2, 1 to 3, all these dimensions we have measured it. And then what we have done is, first month, what is the distance between this ball plate in the same one? Then 6 months, what is the distance? What is the exactly the reading? Then 1 year reading, difference between 1 to 6 months and difference between 1 to 12 months. That we have taken it here. Okay, and this we can do it as a statistical analysis. You can see 1 to 30, 1 to 31. Then all these dimensions can be made a statistical difference here. Okay, when we make it in a horizontal position, this is a box plot, dear friends. Here, as you can see in this box plot, the measurement here is minus 0.04 to 0.025, and 1 to 12 is in fact slightly increased, but it is very much less than that of the yaw error of the CMM machine. That's why we can say that this is very stable. The maximum standard deviation in the year span is 2.285 micron meters. So this is the only difference here, because now we have used, in fact, instead of ceramic ball, we have used a zirconia ball, and because of that, this costing has come down very heavily. I have done one more research with the ceramic ball, that we use it for probe qualification, and believe in me that it was only 2.21 microns, that is 0.07 microns only we could retrieve it. But at the same time, if we make a cost analysis, in fact the cost goes 3 times more than that of the zirconia ball. So this is very much in process, in acceptable here. Now we have made some graphical summary here and Monte Carlo simulation what will happen. But before that, as you can see, the correlations are being plotted from 1 to 6 months and 1 to 12 months. Okay. And the correlation here is 0.973. This is the correlation here, which indicates a very positive relationship. So this is 97% of the accuracy restoration, at the same time accuracy retention. That is what we have assured here. If we see the cross correlation function table here of Six Sigma tools here, you can see that is all the sixth reading only is going out, that is minus 0.01282. So it means that dear friends, that is minus 6 and plus 5, that is 11 months. It can retain the dimensions up to 11 months. So once we, let's say, we have gone to the higher level of CMM and we measure the dimensions by using SPAT probe, up to 11 months, up to 11 months, we can retain this amendment here. So linear displacement errors are XYZ axis, vertical straightness error XYZ axis, that we can cope up with this by using this artifact. Horizontal straightness error also XYZ axis. Then roll angular error is a Z axis. You can see pitch angular error, I can do it. As I told you, the roll angular errors X and Y is not possible with this artifact. Okay, because it requires the waviness, certainly waviness. And what we have doing the research right now is to include this XY also. And I'm very sure that next year I will be able to present this to all of you, dear friends. Pitch angular error, also XYZ axis, yaw angular error, and the squareness error. These are all possible to compute by using this artifact here. Okay. So as you can see, then again we have made a certain analysis. That is how we can retain this position by using the different ball plates here. And this autocorrelation graph also suggests that we can retain the dimensions up to 11 months, in fact. So we have made some setup now. Setup about how to keep the artifact in what orientation so that we can calculate these particular 19 errors into this. Vertically diagonal, that we can make it. Vertically diagonal opposite side, we can make it. Here now you can see setup 1. In the setup 1, what we have done is we have kept this ball plate directly on the CMM. As you can see, this is the ball plate directly kept on CMM. Here in this setup 2, this ball plate has been raised up to certain height. Okay, maximum height. Right. Now in setup number 3, you can see we have kept this particular ball plate here, that is vertically standing on this side. Okay, in setup number 4, this side, that is perpendicular to the previous position. Then setup number 5 diagonally, and setup number 6 is diagonally. So diagonally we have kept it here, one and the other. Right. So this is how we can develop here, dear friends. Then in setups, we computed what is the ball position, 1 to 2, 1 to 3, 1 to 4. These distances we can accommodate. And in everywhere, this particular distance we want in calculation for all setups. Let's say 1 to 2, 1 to 3 like this. So this can be very well programmed, dear friends. Now our experience is up to 32 minutes it takes to compute all these dimensions by any CMM. Okay, so at one setup. So one setup makes it 32 mm, another setup makes it 32 mm. So the relevance is like this, that if you want to measure, let's say, a cylindrical bore which is having a angular position, then we can make it setup number 5 and setup number 6. These are very important for all of us. So from these setups, we can actually calculate the y horizontal straightness. We actually calculate the y yaw in microns, or of course, everything is in microns only here, right? So horizontal straightness, y yaw error that we can make it, and these are all the calculations that we have made it here. Y horizontal straightness, then horizontal straightness in microns that we have made it here. You can see x straightness, horizontal, x, y, then all these positions we can calculate the errors here. In setup 2, now in setup number 2, you can see this is a nominal x pitch in microns that we can calculate. At the same time, you can see x linear calculation also we can make it just by distance. Formula for this, y linear motion we can make it here, and y pitch. Most important, dear friends, is the y pitch. Okay, so how much is the yaw error that we can make it here? So we have taken one CMM which was very much error prone, so that we can actually see what happens with this y pitch here. Okay, so setup number 3, in that we can calculate z linear position. As you can see, this is a setup 3 here, z linear position. Then x yaw position we can compute here, that is distances 17, 18. Actual means what was this with a higher CMM? Higher CMM, what was the distance between 17 to 18 by using SP probe? And in our CMM, what is the actual dimension? That we can easily compute here. And this is how we can calculate x vertical, z horizontal straightness, you can see. Then in setup number 4, we can compute y vertical straightness. So in fact, dear friends, that particular diagram which I shown you as a block, that we are converted into the balls. And this balls is giving us a particular statement here. Z roll is also possible by using this particular artifact. You can see volumetric deviation is possible by using this. Volumetric deviation is possible by using this. So in the setup 5 and setup 6, we can develop. These are the errors. And then when I plot one diagram entirely about all these 19 errors, you can see this is the particular characteristics of that CMM that it reflects into this. That is x linear, x pitch, and you can see x yaw. So y yaw is our basic position. That is what we wanted here. And this particular thing that we can show it. So whenever possible, by spending some 144 minutes, 144 minutes means 2.5 hours to 3 hours, we can compute the entire interim check of that particular CMM. Up to 11 months, it can be cross-checked. At the same time, there is no operator, extra operator is required. The same CMM operator that can do this particular analysis. As you can see, this is in the MATLAB. We have tried to make the equation, because in statistics always, whenever the equation is not possible, we go for statistics. But we try to make it here. But at the same time, there are some residues that I must admit. Even for the 7-degree polynomial, there were residues. So obviously, the statistical behavior of this particular machine tool is probably the most important aspect here, friends. Here. Okay. So this is how we can make the characteristics map of that particular CMM machine. That is what has happened in x-axis, what is happening in y-axis, and what happens in the z-axis. So these are the codes that we have developed for linear comprehension. And at the same time, dear friends, this is the most important feature in our research that we are trying to make it. Obviously, there are residues and more research work is required to make these error statements. So these are the 3 error statements of that particular CMM, so that if there is some error in that pitch and sphere number, we can put this into this, and we can actually compute the compensation value of that particular CMM measurement, which is the most important thing. If let's say, for example, now CMM measurement, it shows 45 mm diameter, and if you know its computation value, then obviously we can understand that how much will be extra amount because of CMM error it is committing in the computing. That is, we call it as uncertainty. But only just saying that it is uncertain, we are not adding to that. We are adding that uncertainty measurement as a compensation for this particular method, dear friends. Okay. So with this, we can say here that if let's say the sphere number 4 and 7, these are its optimum coordinates that we picked up. The corrected distance is 150.007 as compared with 150 mm. So 150 mm was the nominal range here, and the distance reported by the CMM is 150.70. In fact, which is very closer to the calculations demonstrated. So by using the calculations, I'm very proud to say that we have achieved 99.26%. In fact, at very equivalent. Sir, am I audible now? Yes. Okay, all right.
Yes, sir, you are very well audible.
Okay, thank you, sir. Thank you. So I will just share it once again. Yes, sir. Now I think it is okay. Sphere number 4 and 7 you are able to see, na? Okay, all right. So this is the so here this is the program that we have made it in ArcoCAD software of the CMM, and I'm very much thankful to Accurate Engineering for helping me all this doing this particular research here, Accurate Engineering in Pune. So here we have made this CMM program. This CMM program is also available in the along with the kit of that artifact. So you have to just load into that program, and especially this can work in PCMI DMS also. In other software also it can work in that we have cross-checked, in fact. Okay. Then next one here, dear friends, is compensation mapping. Basically, we don't know where is the job to be kept on that machine table. Now, let's say, for example, I'm measuring only this mobile phone. I can keep the job anywhere. But which part of the machine tool is the most accurate? For that, we have made some research by using Monte Carlo simulation. And in this simulation, we have done some runs through this simulation here. And as you can see, we have understood that this particular machine, which is in the ball plate of 9 to 11, 9 to 12 and 9 to 17, in fact. So I will just say here that is 9 to 17, this side ball, this particular dimension is having more errors as compared to the other balls. So don't keep the workpiece here at the edge of this, keep it here somewhere. And as you can see, this particular diameter ball plate here, that is 70 to 24, it is been there. Now, as compared to the air compressor, which is available below the CMM arm, it creates a lot of errors, in fact, because when we spend that air down below the CMM line, it creates a waviness that obviously we require. We know here. That's why probably this is what is showing here. But the standard deviation of this entire ball plate can be measured. In fact, in this, I would like to suggest that any machine tool, if you take, let it be a CNC machine or let it be any other, where the job should be kept, that research can be done by using this particular type of method. Okay. So this is the conclusion here, that we can calculate so many errors out of this ball plate. At the same time, it's same error that we can do it here. And when we make this as a MATLAB, in MATLAB, how this errors looks like of the CMM. In fact, it should be a very straight one here, but this can be look like this. And you can see those where there is a red color, please don't put the workpiece there. Now, let's say, for example, here 300 mm, the workpiece or the measurement which is there is not a good sign. So therefore, here we can do lot of analysis at the ground level or the initial level. It means that for the vertical dimension, this particular CMM is not safe. It is producing more uncertainty into that. So therefore, we can make it up to even here, you can see 500. So this is probably where we have to find out that there are some errors in the machine tool, and accordingly, we can do some research work into this. So this is how the measuring volume it represents, dear friends. So now with this, I will just like to make a conclusion here that as per the, we'll see some of the part once again. So this is the CMM here, you can see, and this particular gantry, it moves here, right? You can see this is it moves here, and we make it some air falling through this. At the same time, this particular is a suspended probe. So it creates some measuring volume problem here. And as you can see in the ISO 11530, specifies evaluation of measurement uncertainty. So in this artifact, it is measuring the uncertainty. At the same time, it results by a CMM and using calibrated workpiece. So this artifact, we actually know its dimension and other things. By defining the experimental technique also, we know this, right? By simplifying the uncertainty evaluation of the measurements being carried out with the calibrated workpiece. So this all, if you can see, this all is being achieved by using this artifact. And therefore, ISO not only just gives us the guidance, but at the same time, it gives us a roadmap for using CMM where we can carry it out. So thank you very much to Ashutosh ji that you have given me time for this. And with this, I end my presentation, dear friends, here about the case studies. Now I will like to take some queries if possible from anybody of you, or from my side, whatever best, I will just explain this. Much more research is required. And dear friends, let me tell you, as the NPL says, or as Legal Metrology says, Metrology Society of India says, MAPAN says, that we require an Indianized solution, which is giving us a low-cost solution for our industries. We need not to import always. So wherever possible, we should do import substitution, and at the same time, we can carry out this particular research in the Indian context. Thank you very much, all of you. Thank you. Sir, now Ganesh Jadhav sir is online. He is with me only.
Thank you. Sir, can we, he is with you or he is somewhere outside?
He is with me only, sir. But only thing is that you just...
Sir, can you open your camera? We are not able to see you.
Actually, sir, I am trying to open my camera. It's open, I think. But I don't know.
Or in another mobile, you can join the same way and open one camera so that we can see you.
Yes, sir, obviously. Sir.
Please.
I think, sir, sir, can you start?
Yeah, in the meantime, yes. In the meantime, I would like to request the expert to kindly start.
Yeah, Ganesh Jadhav, sir.
Yeah.
Just I will introduce him.
Sir, you please unmute to Ganesh Jadhav, sir.
He is with you, na, sir?
Yeah. No, but he is having laptop different, sir.
Okay, different. So he can start his camera. Mr. Ganesh has joined.
Yes, sir, he has joined. And
okay, but his camera is also not on.
Yeah, you can make it panel. You can give some rights to him, sir.
Can you, Mr. Yeah. So the another expert is Mr. Ganesh Ashok Jadhav, who is the owner of Avni Industries Pune. He is an ISO and VDA certified auditor, Master Black Belt Sigma, Six Sigma from IIT Kolkata, first and second party auditor in the fields of quality environment, health and safety, TPM, energy, automotive, IMS, and innovation. He is BME and BE in production and industrial engineering from Shivaji University. He has a lot of experience, and being an entrepreneur, he can certainly help us how to do this type of testing and what they are doing in their field. Dr. Yadav, please, sir. Dr. Yadav. Dr. Yadav, please start, please. We are not able to hear you. And we are not able to see you. Dr. Jadhav? Dr. Kulkarni?
Kindly unmute him, sir.
I can't. Okay, he's from another camera. That means just a minute. He started. Is it okay?
No, sir, not yet.
Dr. Ganesh Jadhav. Sorry, I'm sorry. I'm sorry. He was not. Now he can do that. And he has to present now.
Yeah, yes. He is present.
I'm sorry. Actually, I think I was not aware of that. So he was not there. Now he's there. Can he start his camera and mic? Dr. Ganesh Jadhav? Yes, Dr. Jadhav, but we are not able to hear you. Kindly unmute yourself.
How can you hear me?
See, Professor. Yes, now you can speak. No, we are not able to hear you.
How can you hear me?
Yes, sir. Yes, sir. Very well. Very well. Dr. Jadhav, please. And can we see Dr. Kulkarni also? Laptop? Yes, thank you. Thank you. Thank you, Dr. Kulkarni. Thank you very much. Kindly continue. You can present yourself. Now you can use your camera. Sorry, this presentation. You can share your presentation. Professor Kulkarni. Yes, now it is okay. We can see. Sir, no, we are not audible. You are not audible, sir. I'm sorry, we are not able to hear you.
Ashutosh, sir, is he audible?
Yes, sir. Yes, sir. Now it is audible. Please.
Okay. share this inputs which are related to the ISO IC 17025. 2017. I think all of you know there are so many different standards in the ISO, like ISO 9001 2015. This is related to the basic quality management system. Other than this, there are certain specific guidelines for automotive industries. Then there are certain guidelines for environment management system and certain guidelines which are related to the food related standards. Now, this is the specific standards which are related to the requirements which are related to the laboratories, correct? Testing and calibration laboratories. And
Your voice is not there. Sorry, your voice is not there. We are not able to hear you, sir. Mr. Ganesh, we are not able to hear you. I'm sorry. Dr. Kulkarni, we are not able to hear him. Dr. Kulkarni? Mr. Ganesh, we are not able to hear you. Atulji?
Yes, sir. We are hear you.
But we are not able to hear Mr. Ganesh, na?
Yes, sir. Yes, sir.
So, how what to do? You just ask Mr. Dr. Kulkarni that we are not able to hear Mr. Ganesh. He is speaking, but we are not able to hear.
Sir, we calling the Dr. Vinay Kulkarni, sir.
Yeah, Dr. Kulkarni, please, because he is with him.
Yes, sir. Yes.
Please.
okay. Now, can you hear me? Hello.
Yes, sir. I am hear you.
Yeah. Okay. So now I will just give the brief about what is the risk-based thinking in the ISO IC 17025. So risk-based thinking means what? Where we have to identify the all risk in the measurement. As already Dr. Kulkarni sir shared, there is a errors in the measurement, and these errors occur due to the operator or due to the some placement of job or due to the inbuilt errors in the equipment. So that's why we first need to understand what are involved in the measurement, and that we need to understand, and that is the first important thing in the ISO standard. Then we have to address all the risks. For that, basically, as we see in the ISO and certain other standards, we need to go for the measurement system analysis, which will give us the inputs on the
I'm sorry, again, your voice is not there. Dr. Kulkarni, voice is not there. Atulji, again, his voice is not there.
Yes, sir.
So you just inform him that we can close this session. And Mr. Ganesh, your voice
Yes,
is
sir.
regularly breaking. We are not able to hear you.
regularly.
Yeah, your voice is regularly breaking. We are not able to hear you.
Now is it okay?
Yeah, now it is okay. But please speak in such a way, and you just try to understand, try to listen us, so that you know when you are talking and we are not able to hear, it will be useless, waste. Now you start.
Okay.
You start, please.
I think now it is comfortable. Wise.
Now it is comfortable. Please speak.
Okay. So in the ISO, we need to understand the risk.
Actually, you want to share, you want to explain us about this 17025 standard or something about CMM?
Yes. No, this is related to the standards, not related to the CMM. CMM already Dr. Kulkarni has covered.
Okay,
I thought that
you are doing it practically. What type of experiment you are doing? Anyway, please continue. Please. Again, your voice is not there, sir. Mr. Ganesh, your voice is not there. Mr. Dr. Kulkarni, we are not able to hear him. Atulji, we are not able to hear him.
Sir, same here.
So what we can do, I think we are now, it is the way we are wasting the time of other participants, and it is not good that we are wasting the time. So my request will be, you just talk to Dr. Kulkarni. He should open his camera or his this
Sure, sir.
speaker,
Recalling.
so that yeah, we can talk to him and we can take questions if the participants have, because it is wasting time. We are wasting our time otherwise.
Okay, sir. Okay.
Please. Otherwise, we will close it, na? Why to waste time?
Yes, sir. Yes. Yes.
Formats and can indicate the possibility. If there is a possibility of implementation or application of these guidelines, that also we need to ensure. If we can able to ensure that whatever the guidelines related to the standards, we can able to meet or not. That is the requirement. And as I already explained, we need to go for the risk-based thinking. That definitely comes from the 9001, and that risk-based thinking is which is related to the identification of risk and mitigation of the risk. We have to start reduction in the risk which are involved in the measurement. Also, the standards cover the process approach requirements, then preventive action, which is based on the actual implementation or where we get the wrong results. There we have to get the preventive action in the routing base, and we have to identify what are the risks which are related to the measurement in the negative sense. All these things we need to understand, and accordingly we have to go for the measurement system. So clause number 1 is the scope. So this covers basically what is the laboratory scope and what are the activities, what are the readiness, how many numbers of persons working in this, then confirmation, what are the different types of equipment we will use in the calibration. So that we need to understand in the scope. Other than this, second clause covers normative references. Normative references, this gives the references which are related to the other than these standards, like ISO, we need to follow guidelines 99. Then we need to follow ISO IC 17000, and these standards are which are related to the which we need to understand as the reference standards. And in the terms and definitions, whatever the terms which are we normally not use in the regular inspection, like as I explained, in management review meetings, then there may be certain terminology like calibrations, then there is a risk, then there is a process approach. All these terms and definitions we need to understand in this standard. So conflict of interest. Interests do not exist which are related to the measurement. Then freedom of conflict of interest. All these terms and definitions which are explained in the clause number 3. The clause number 3 is basically related to the terms and definition. And this covers testing, calibration, sampling, all these things. Other than this, clause number 4, basically what we need to do, identification of all risk and opportunity in the organization or in the measurement. That is the first we need to understand for implementation of these standards. Then second is the plan and action, the address on the risk. That means we need to avoid the risk. Then we try to eliminate the risk, and we need to try how to mitigate the risk. That is the of the standards. Then implementation of the plans and take the actions. This is linked to the PDCA approach. Plan for the measurement, and if there are certain errors occurs or if there is a certain maybe you can say problems occur, there we have to take the actions and check the effectiveness of the actions. That is also another one important thing. And as a PDCA, we have to take the actions and we have to address that whatever the action we have taken, these actions must be sustainable actions. Then clause number 5 covers the structural requirements which are related to the standards. These are legal entities which are very important thing. Identification of the management. Define the documentation which are related to the laboratory activities. Meet the requirement of ISO standard. And understanding the customer voice or customer specific requirement. Then what are the regulatory and regulatory requirement that also we need to cover. And what are the facilities? What are the temporary facility and what are the mobile facility? And what are the customer facility which are involved in the inspection? That also we need to cover in the structural requirements approach. Other than this clause number 6 cover resources requirement. So resources is nothing but the person or skill of the person. inspector skills, their qualification, then what are the facilities we required for the inspection, then equipment, then system and support services. So this clause covers related to the all the requirements which are called as the resources for the inspection. Here we have to see, as I mentioned, we need to understand the competencies requirement, education, qualification, training of operator, technical knowledge, skills, and experience of that person. Then in the laboratory requirements, we have to see the significance of the deviation or what are the equipment which are already available in the laboratory, and communicate the role and responsibility of each and every responsible persons related to that measurement activity. Means that is nothing but the communicate the personal, their duties, responsibilities, and authorities. Environmental conditions also we need to address, where suitable environment is the requirement of the standard. Suitable environment is nothing but the not necessary that whatever the temperature which we need to maintain for the measurement, that we need to understand, and that we need to write down in the procedures. Okay, what are the suitable environments for the measuring of that activity or measuring with the help of that instrument, and what is the criticality in the measurement. Accordingly, we have to adjust the suitable environment for the measurement. Documentation requirement for the environmental conditions we need to address, and monitor, control, and record the environmental condition. For example, if we see in the CMM, we need to monitor the humidities, we need to monitor the temperature, we need to monitor the quality of argon gas. So all these things we need to monitor every day basis so that there will not be error in the measurement. Measurement in the control facility, that also included in the standards. What is the control facility? The control facility is nothing but the whatever the required environmental condition. For example, if we require the closed environment condition, that we need to understand. Ensure the environmental condition which meet the performing for the controls for the measurement. That is the requirement. Against that, another one important thing is the condition of the equipment. So this covers availability of the equipment, then specification which are we need to place in before going for the measurement. Then we need to understand the calibration. Definitely, whatever the equipment we will use for the measurement, that must be calibrated. Establish calibration program and calibration status. So these are the certain requirements. As I mentioned already, if possible, we go for the measurement system analysis. Equipment record means equipment record nothing but the equipment history cards that we need to monitor, and immediate checks of the instrument. So that are the requirement of the standards. Other than this clause covers, if you see the procedure reviews, then inform customer what are the methods required by the customer. If not appropriate, you have to go for the outside laboratories. Then repeat the contract reviews. Normally here we use the terminology called as the agreement of inspection, AOI. Then cooperate with the customer for their clarification of the customer requirement which are related to the measurement. Means here, if required, we have to see the or validate the equipment with the results. Then the return of the records, and inform customer if there is any deviation in the measurement. So all this documented data is we need to monitor to sustain this requirement of the standards. Then selection, verification, and validation of the method. So which method and which procedure we need to adopt for the inspection. For that, we have to prepare the action plans. Then we have to use the latest versions equipment. We have to use the latest version of standards which are available in the market, and if required, customer standards we need to verify. And other than these, there must be sampling plan, sampling method, and requirement is the how we retain the record. That is another one requirement, and calibration. In the technical records, we need to monitor the sufficient information related to the inspection activity, related to the instrument. Then we need to monitor the tracking of the previous versions. We need to evaluate the uncertainty in the measurement. That obviously uncertainties we need to monitor first, then evaluate all the calibration related activity with the help of different labs. We have to validate the results and report the results. Report the results in normally, if you see there where we have to review and authorize before the release. We need to monitor the complaints related to the inspection activities and monitor the non-conforming works and control of data and information as per the management system. Other than this clause number 8 covers which are related to the management system documentation part, where we have to understand what are the documentation required we need to monitor, and control of record. We need to prepare the procedure for the control of record. Retain how to retain the records. And last is nothing but the improvement in the inspection activities. So these are the requirements which we need to cover in the standards. Okay. So corrective actions, definitely to avoid the repeating non-conformities, we have to evaluate needs and action for the implementation, review the effectiveness. We need to update the risk and opportunity, make the changes in the measurement system, and retain the records. So these are the things we need to cover. Thank you. Any doubt? I think
Thank
this is
you.
very short time for the.
Thank you very much, sir, for your brief and kind presentation. I would like to thank Professor Kulkarni, who has explain all this in a very well manner. I would like to request all the participants to kindly switch off their mics. Atulji, you are here.
Yes, sir.
Please make all the participants the panelists so that we can take the pictures for
Okay,
our
sir.
all portals, social media portals to upload. Kindly remove the presentation, please. Sir, Dr. Kulkarni and Mr. Ganesh, we would like to share your presentation with all the participants in the group as well as this video in the group, so that the other participants who could not listen or could not understand, they will be benefited from all of this. With your kind permission.
Yes, sir. Sure, sir. Absolutely.
Hello.
Thank you. Thank you very much, sir. So if anybody wants to ask any question, you are free to ask from our experts. I have also shared my mobile number for addition you in the group. If you wish, you should be added in the group. Certainly, we can add you. You kindly share me your name, your organization, and the city so that we can add you in the group and you will get all the information at the same time. But kindly give me your name, organization, and from which you belong so that you can be placed in the right group for obtaining the information. Anybody wish to ask anything or anybody who wish to speak anything or who wish to say something, you are most welcome, all of you. Anybody who wish to ask anything in the regarding this presentation or regarding this today's discussion or something else, or he want to add or say something, you are most welcome. Please, anybody.
There was one question.
Yeah, please.
Can we calibrate CMM with caliper checker? Sir, caliper checker is itself is having problem with uncertainty. Therefore, one equipment having itself is uncertainty. We cannot check with.
No, I'm sorry. Your voice is breaking. Well, Professor Kulkarni, you understand what he's asking?
Sir, actually, now, am I audible now?
Rest of the participants are requested to kindly switch off their mics. All the participants are requested to switch off their mics, please. Yes, sir. Please speak.
Sir, there was one question. We cannot use caliper checker for CMM checking, interim checking, because caliper checker itself is having a lot of uncertainty induced in it. So one equipment which is already uninduced with lot of uncertainty, we cannot check with other instrument. That is the basic gauge repeatability and reproducibility study that we have made itself. So we need to check first of all whether that instrument is having uncertainty less than 5 microns or not. And definitely caliper checker is having more than 5 micron checker. So that is the reason why I don't recommend this for checking.
I think for this caliper checker, we use the slip gauges.
Right. Absolutely. Sir, but slip gauges also, there will be a lot of stacking problem because we are not checking 1 mm or 2 mm. We are checking a huge mm there. That is 300 by 300 by 40, 300 by 300 by 300 box. That is what we are checking with CMM. So obviously it will be a large box. Therefore, something like an instrument which is homogeneous should be used.
Okay, so I think this slip gauges, we have different technologies, even in this infrared radiation or what we call laser interferometer. We generally use for the calibration of these slip gauges, this infrared laser interferometers, calibration of this, and I think with the help of these slip gauges, we can calibrate 1A caliper. I think Professor Kulkarni will be maybe the right person to reply. Am I right, sir?
Sir, absolutely, sir. Absolutely. We can check the form of an GD&T form, but actual calculation or actual measurement not recommended by laser interferometer.
Okay.
That requires a physical artifact. If at all we want to check it actually, what is the actual dimension?
Yes.
Right, sir.
Good. Very good. Anybody else?
Hello.
Yeah. Please.
Sir, good afternoon. This is R.K.
Good afternoon, sir.
from Bhopal, sir.
Good afternoon, sir. How are you?
Fine, sir. Sir,
Please.
my question is to...
You are looking very beautiful over from here. We can see you.
Thank you very much, sir. Sir, my question is to Mr. Kulkarni regarding CMM, sir. can we check cylindricity and circularity on CMM machine for highly precision component like spool and sleeve of pressure valve?
Sir, actually, highly precision means that definition has to be very clear.
Highly precision means
Ganesh, will you please allow him to speak?
cylindricity.
Just move the camera towards him. Computer, your computer. Yeah.
Yes, sir.
It's okay. Yes, sir.
Yes,
Please.
Sir, highly precision means cylindricity requirement is 2 micron on spool and solution.
Right.
So
right.
2 micron can we check on CMM machine or not?
Sir, the CMM machine accuracy depends upon the probe. If you are using SP80 probe, then you can go up to 0.02 microns.
Okay, but it is very expensive, sir.
Yes, obviously, sir. 35 lakhs the cost is. So depends upon the probe, sir, because the probe is everything in CMM.
Okay,
Right,
generally,
it is,
what
it is
what
suspended.
what I'm telling that, okay, recommendation is that you have to use tele-round machine for that. So
Yes.
you're telling that probe, if you have that probe, then you can check
Yes.
it. Otherwise, you check on other machines.
Right, sir. Right. Absolutely.
Sir,
Because
thank you very much, sir.
yes, sir. Absolutely, sir. If you can make a physical artifact which is retaining the accuracy up to 0.2 microns, then obviously, sir, we can go ahead with that. But that will require a very sustained meteorological conditions that we have to make the analysis completely. Sir.
Correct, sir. Thank you, sir.
Thank you very much. But my request with all the experts to kindly share your experiences, because you people who are working in the field since long, you can actually enlighten your other participants, because the purpose of these type of seminars is to upgrade the standards of all the laboratories, of all the people. This is the only purpose. So my request is, if you feel you can say something better, what we are understanding, you are always most welcome. Because I tell you one thing, it is not possible that anybody is expert or in any field, but the person who is working in the field since long, he knows the ups and downs of the field and ups and downs of the test. So my request with all the participants, and we always search of good experts, good speakers who can let us or let us enlighten us for the new technology, new testing, and new calibration. Thank you very much. Thank you, Shivasa sir. Anybody else?
Thank you, sir.
But it should not be one-sided. It should be both-sided.
Yes, absolutely, sir. Yes,
If it will be like this, and all the participants will switch off their cameras, switch off their mics, then I would, from the very beginning, we can put like this, so that everybody can listen, everybody can raise his hand and can ask. Yes, Mr. Rohit, please. Rohit ji, पूछिए. हाँ, पूछिए रोहित जी.
Thank you, sir. First of all,
Please.
I would like to thank Mr. Dr. Lisa and Dr. Nesh, sir. You both were excellent in your respected field.
Thank you.
Thank you, sir.
Sir, my question
Vice
is,
President,
how
we are
can
not
I
able
get
to
these slides?
We are not able to listen to you. Yes, all the presentation, I'm sorry. From now, I will try that because videos are uploaded in the portals, Facebook as well as YouTube, but the presentations are many times are not being uploaded. What I will do, I will try to
I will
upload
send, sir.
very soon at one place on our website. We are just developing a website on our government portal, so that you can see all the videos as well as all the presentations, and you can also find your certificates. Whosoever has attended any of the seminar, he can find the certificate, he can upload the certificate from the site. Very soon we are developing it. Maybe within 1 week or so, you will get all this information available in the public domain.
Absolutely, sir. I will send you
Okay.
the PowerPoint presentation immediately.
Sir, you can send me the presentation.
Thank you, sir.
Yes,
I will.
I'm sending you, sir.
Thank you. Anybody else?
Both of our presentation I will send you, sir.
Yes, we will share it. Or if there is nothing, then we can close this session. I don't want to waste the time, a single moment of anybody's life. Because I understand that you must be busy with other a lot of works, and we can close this session. Thank you very much. We will meet next.
Thank you, sir. Thank you, sir.
Next presentation will be on Choti Diwali. Saturday is the Diwali. Choti Diwali. We will be having our session on next Saturday, 11 to 1. Thank you very much. Thank you all. Bye. Good day. Thank you.
Thank you very much.
Thank you.
Thank you, sir. Thank you very much.